from alpha was taking me from susceptible to infected. So it's alpha times S naught, which is just the initial number of susceptibles, over gamma. So if you recall, alpha, so this is alpha I, the change from susceptible to infected. That's what that alpha is. And then gamma is the rate at which people are leaving infected and going to recovered, which we're kind of out of room on the board. But remember, alpha was the average number of contacts per person times the probability of transmission. Okay, so this is what we're trying to get a handle on right now, right? So this is what we're trying to change. So we can affect the R naught. We are changing this using social distancing, right? So the average number of contacts per person has gone way down, right? That's why we need to all not go to the grocery store. Well, we still need to buy food, right? But we're not going to the bar and hanging out with all of our neighbors, right? So we're bringing the average number of contacts per person down by practicing social distancing and staying at home, right? So that's changing the R naught. We're trying to bring the R naught down. And then the probability of transmission, we have some control over that, basically like by washing our hands. So if I do, well, I mean, I guess maybe like masks. I mean, I'm not a biologist. So that is all alpha, which is in this R naught number. So the epidemic is exploding right now because I actually, people are estimating, you can Google like current estimates of R naught. Like people are doing this calculation. But the number of susceptibles is still extremely large, but if we had a vaccine, we could bring that number down, right? And then gamma, there's not much, that's just the course of the disease. Does that kind of answer your question? Plus maybe a question you didn't know you had.
Yeah, no, that's interesting. I mean, if R naught's greater than 1, it just means it's exponential, right?
No, it means, like, if R naught is greater than 1, it means you're going to have an epidemic.
Yeah.
If R is less than 1, it means the disease dies out.
Yeah. No, I mean, yeah, that makes sense. Yeah. I mean, I get that, but what's interesting, I mean, if it is over 1, though, then it would be an exponential curve, though, wouldn't it?
At the beginning of the epidemic, it's an exponential curve, yeah.
Yeah. What's the inverse of an exponential curve? I mean, if it's what?
You mean what's the alternative?
Yeah. What's what's a downward exponential curve?
Well, a downward exponential curve is exponential decay, but like that's just like math. But if you drop like a disease, like the thing is, if we had dropped a disease into our population that had a lower R naught, it wouldn't have spread throughout the world.
Yeah, that makes sense.
So it's sort of like it's really like that's why it's like it has a naught for like initial, right? And it's based on the initial number of susceptible. So like I think of the world as like one vast tray of like cherry tomatoes, right? And we drop one that are like bouncing around and interacting with each other. Oh, and if we drop like one sick cherry tomato in, if it's R naught or less than 1, like some small number of people would have gotten sick and the whole thing would have died out.
Yeah.
But that is not at all what happened. But we can manipulate R naught, right? Like we're, as a society, making this decision to stay at home and like decrease the average number of contacts per person to like slow down the epidemic and try to get a handle on it and hopefully buy some time so that we can get a vaccine and reduce the number of susceptibles. Great questions. Anybody else want to? Questions are the fun part of teaching.
I'm Googling R naught of coronavirus, but I can't find it.
Yeah, there are some estimates. I'll follow up with that. I'll put it on the website, the Adept Prep. So if you go to the Adept Prep main page, then you pretty easily can find the COVID-19 math page. And there's some cool videos on there too. But I'll find some of that and put it on there.
Cool.
Other questions and comments? Those were all really good. So bring it on. More, please. I mean, we've gone on for a long. Yeah, right. Yeah, it's been an hour and a half almost. So, and that's a little longer than most people can concentrate on math. But if there are more questions, I'm happy to try to answer them. Okay.
No more questions, I guess.
Bonnie, are there any raised hands in the chat?
No raised hands.
I don't even know how that works. Here, I'm going to raise my hand, Bonnie, and make sure that you know how. I can. Yeah, okay. I'm going to lower my hand. Okay. Oh, well, thanks for coming and doing math and answering questions and asking questions.
That was fun.
Cool, Ben. Thanks for doing this.
Yeah.
My pleasure. Oh, let's see. Myra says that she thinks R naught is around 3 right now.
Oof.
Oh,
Seems high, right?
that's very high.
Jesus.
Oh yeah, and Joanna has this fun quote too in the chat. All models are wrong, but some are useful. That's a great famous quote. I love that one. But yeah, Nate's other point really that Myra is kind of hitting on, that Nate kind of touched on too, is that the situation is changing all the time, so you do have to keep changing your model and running new models, right? And also what I would really like to do with my students is get people to do different graphs of different parts of the country to see where people are making more aggressive changes, where there's more aggressive policies to try and contain the disease compared to where there aren't. There's different parts of the world and different parts of the country, so we could do different graphs. And there's a really cool one of the videos posted on the on that part of our website. There's this really cool video showing kind of how it's wrapping up in different parts of the world, or tapering off in different parts of the world. It's really cool. I might just do a little question and answer explaining that, because the video explains it beautifully but very fast. So I might just do another, if people are interested, another just explaining. It's really cool what they did with it. Okay. I don't see anything else in the chat. All right. Oh, yeah. From Radiolab podcast. There's another podcast that was talking about R naught really early in the epidemic. There's this cool podcast. I'll put that on the website too. There's this cool science nerd podcast that was talking about R naught months ago. Oh.
Months ago. Yeah, back when it would have been good to start doing all the stuff we're doing now.
Yeah, right. I know. We really could have gotten ahead of this. It really didn't have to be like this. We could have.
I mean, because that's the most important thing, is where on the curve you pay attention. Once it gets wild, it's wild.
Well, you can see in that graph, of the deaths in the U.S., right? It's 170 and then 1,000.
Yeah.
Right? But the thing of it is yes, but we were not the first country. So we already knew it was coming. There was no reason to think that the United States was going to have a special exemptions from the laws of nature. So yes, if you were only looking if you're only looking in your own little tiny viewfinder, then it's shocking. But if we saw this tsunami headed towards us. Like, we definitely, anyways, we're doing what we can do now. I mean, the one, like, bright spot is that it's not actually, like it's up to the people, right? Like, we're the ones staying home. Like, even if the government gave us permission to go to work or, like, do whatever, we could still not do that because we're not stupid, you know?
Yeah.
So, I mean, at some point we would like to see each other in person again, and, like, people need to go back. I mean, half of my household income is gone because my partner is worked in a restaurant, you know, so we would all like to go back to work and to see our friends, but and go to ballet class in person.
One correction is just that when I said, Nate asked the question about removed, the point is that the susceptibles, I said sick when I meant susceptibles. Susceptibles, the number of susceptibles and the number of infected is together driving the dynamics of the situation, because the susceptibles bumping into the infected is what's, like, increasing the situation. So those are the big drivers of the situation. Okay, thank you for hanging in there through the bad video editing. I appreciate your patience with that, and please share any questions that you have or any ideas for follow-up info videos or whatever we're calling these. Two things that we have planned. One is the big remaining question on this issue is, where are we on the curve, right? So is it flattening? When is it flattening yet? I mean, that I can kind of answer. Is it flattening yet? So because I can kind of answer the question, is it flattening yet? Well, the way that we're going to do that is just compute that growth factor B using, 2 data points at a time, and then compare the calculations. So we can look at day 1. I mean, we probably won't do it on this scale, but we could do day 1, day 2, day 2, day 3, day 3, day 4, day 4, day 5, day yesterday, day today, looking at the different growth factor calculations and see how the growth factor is changing. So when the growth factor starts to decrease, then the curve is slowing down and flattening off. So we can do that calculation. We'll do that in the next video. And then what we want to do, what I am really excited to do, is have somebody do a similar series on the economy, because I think this is also a teachable moment in terms of the economy. So I've reached out to my own old back row econ professor to see if she could do it. And I'm trying not to sneeze. It's allergy season. And if she can't do it, I'm going to start looking around for somebody else who can if she can't. So look for those. We look forward to hearing from you. Thanks for listening and learning.